apparently now there's excellent connection. However, before, not so much. I am going to post the video later. It'll say part 2. And that way you'll know that if you came in late and missed the first part, there's probably a bunch of time that is off from the other one because I couldn't figure out what was wrong, so I shut everything down and started over. I did work out a few just as a reminder. What we're going to see is when we're just simplifying, again, factor the numerator, factor the denominator, and check to see what cancels. Again, a pretty simple binomial divided by binomial. Then what's left is just p minus 5 over p minus 1. I will say that I went back and I checked all of the answers that are given in the textbook and on any worksheets and anywhere. Please keep in mind that if you are asked for the domain, that we do need to account for not only our answer, but our original problem. So if the domain is asked or when the values are not possible, so when p is not possible, keep in mind that we would have to say that p could not equal -2 because p plus 2 is in the denominator, so it can't equal -2 and it can't equal 1. So again, only if the domain is asked. You do not have to list it otherwise. I did start the second problem that I had for review. I have 10x squared minus 20x over 40x cubed minus 80x squared. That's going to be divided by 60x plus 30 over 16x cubed plus 80x squared. Again, keeping in mind that as I'm doing the problems, I'm going to factor as I go. So our 10x squared minus 20x squared is going to factor into 10x times x minus 2. Our denominator, we're going to factor out a 40 from each of those as well as an x squared. Pretty much a good trick is look to see what the biggest value is in the power, and then we'll also be left with x minus 2. The whole point of this again is to cancel, so you should see some common values top to bottom, left to right, that kind of idea. Then we're going to go ahead and notice I've changed the sign for keep change flip to multiplication, and what's on the bottom I'm now going to put on the top. So I am going to factor out from 16 and 80, looks like an 8 is going to be able, actually 16 times 5 I believe is 80, so we're going to be able to factor out an entire 16 x squared, and that leaves us with x plus 5. And then on the bottom, we're going to factor out a 6, and that leaves us with an x plus 5. So what's nice about this is top to bottom in both fractions, we have x minus 2's that are going to cancel. Top to bottom here is the x plus 5's that are going to cancel. At this point, you may need to do what we did in elementary school, which is kind of play around with which direction you want to take things. Over here, 10 and 10 are going to cancel and we're left with 4. However, when we cancel now our 4, we can cancel out of 4 over here, because 16 divided by 4 leaves us with 4. And then we can go ahead and cancel our 6 and 4 to a 2 and a 3. So I am accounting for what's left over. I at least can see right now that I have an x squared on top and an x squared on the bottom, so I'm going to get rid of those, and that kind of cleans things up. With all of this, the way I'm going to write my final answer is one big fraction bar so that it accounts for what's left on top. The only things left on top are the 2 that's still left over from the 16, the x that's over here, and on the bottom, I'm simply left with a 3. So after that whole problem started, we have a 2x over 3. Now again, these first two were just to kind of go over what you looked at yesterday with the 2 questions that were asked already in part 1 that did involve what would be considered our complex rational expressions. So I know there's only 2 of you maybe watching. If you have any questions, you can stop me, but for the video purpose, I am going to move to the next section, which is still simplifying, but we are going to look to simplify doing adding. Yep, lots of noise. Adding and subtracting. So, one of the things that when we add and subtract, I want to make sure that we are remembering that our adding and subtracting is like what we used to do in elementary school, that we do have this least common multiple. And in our algebra classes, least common multiple meant what did the things multiply together. We used to do factor trees where we did prime factorization. But it is the common denominator. And in most cases, it's going to be what do we want that's the same throughout all the denominators. So before, we used to be able to go through 10, 3, and 7 and find what was in common between them so that, and a lot of times it was just mental math. We wouldn't look to write anything out unless the numbers got bigger. But when we think of the prime factorization that goes behind each of these numbers, 10 factors into 2 times 5. So we really are looking at what the primes are. 3 is just 3. 7 is just 7. And when we look at what our LCM is, it is going to be 2, 5, 3, and 7. There's no repeated values. There's no groups of 2s or 3s. So we have to multiply 2 times 3 times 5 times 7. And unfortunately, the LCM, or the common denominator for this problem, ends up being 210. Now, the nice part about our numbers, when we look at how to figure out, that at least tells us if I have 10 in the bottom, the 2 and the 5, I need the other 2 to make that 210. So when we do common denominators, remember we've got to multiply top and bottom by what makes the common denominator of 210. If I already have a 3 in the bottom, I need the 2, the 5, and the 7 to show up. Well, 10 times 7, we end up needing 70 top to bottom. And if I already have the 7 in the bottom here, I need to figure out what is left. Well, 2, 3, and 5 is what I need for the 7. So I'm going to multiply top and bottom by 30. So by writing out the prime factorization, it does help for us to see what's already in the bottom and what else do I need. What's in the bottom, what else do I need, and what's here, what else do I need to make that common denominator. And then it's individual multiplication problems for us to then solve. So we end up with 147, oh, I totally could have done that in my head, over 210 plus 140 over 210 plus 120 over 210. And so in elementary school, that's kind of how we approached adding all of our now common denominators with the numerators. And we end up with 407 over 210. And unless you can simplify, you can leave it that way. I am going to probably guess that 407 on top of 210 is going to have a crazy fraction. I just cheated and did it in my calculator, and I end up finding that I'm just going to leave it at 407 over 210. Shh. Now, in this case, we're going to jump into our work, and we're going to look again. We don't care about the numerator, but we are going to again do our prime factorization. I do the numbers separate from the variables. So again, we're going to take 3, and that's just 3. 4 is 2 times 2, and 10 is 2 times 5. Now, the trick with the common denominator, you have a group of 2's. So you don't repeat each of them. You only write the group once. So when we look at our LCM, we end up with 3 times the group of 2's times the 2 times the 5. So a lot of times when I used to teach junior high years ago, LCM was what's in common for the C and what's left over for the L. So what was in common was our 2's, what's left over are the ones I didn't highlight. So here's our group of 2's, and what's left over is still there. So we find our LCM, or the common denominator for the numbers, is our 20 times 3, which would be 60. So that's just for the numbers. Now what we have to worry about is what are the variables. Now our variables, we're just going to worry about needing the highest for each one. So our variables, of all the ones in the bottom are A's, we just need A to the first because there's only A to the first as our biggest. Our B's, we only need B to the first because that's the highest power in the denominator. And our C's, we only need C to the first because that's the highest power. So through this whole thing, the total LCM is going to be 60 A, B, C. So that means every one of my denominators, I have to get 60 A, B, C. So I have a 3, which means I still need 20. I already have a B and a C, but I do need an A. So I need to multiply top and bottom by 20A. On the bottom here, I already have 4, which means I need a 3 and a 5, so I need to multiply this by 15. I have A and C, but I still need a B. So I put the B, and then I multiply the top by 15B. Again, the whole purpose is to get each and every one of these to be 60 A, B, C. Here, I already have 10, but I need the 6 to make that 60. I already have A and B. That means I need C. And what I do to the bottom, I need to do to the top. So in each one of these, we're going to go ahead and now simplify. Over here, I did the 3 separate problems, but they all grouped over 210 anyway. So what I'm going to do in this problem, just to kind of save room, is I'm going to put my 60 A, B, C, which is our common denominator, and on the top, I'm going to write out the addition. So I have 2 times 20, which is now going to be 40A squared, our plus sign, 3 times 15, which is 45, and B times B is B squared. and minus our 5 times 6, which is 30c. And what I can do is then check, is anything able to cancel before I write my final answer? Which does mean sometimes you may have chosen a different LCM. But what we're looking at is our 40, our 45, and our 30 have a common factor. So 40, 45, and 30, if I factor out a 5, I end up with 8a squared plus 9b squared minus 6c all over 60abc. And now my 5 and my 60 can cancel. So always check to see if you can reduce top to bottom. Okay. Trying to. Okay, so I'm not sure. Okay, let's take a look at the next question. Our 5 over 12x to the 4th y minus 1 over 5x squared y cubed. Again, we're going to look for our LCM. Our LCM on the bottom, we have 12, which is 2 times 3, and we have 5, which is just 5. So unfortunately, when we multiply all of this together, we're going to end up with an LCM again of 60. And then I'm going to look at what my powers are on x. Well, x to the 4th is the biggest power, so I want to leave it as x to the 4th. Y to the cube, to the 3rd is our biggest power, so we're going to leave that there. I don't have any other variables to worry about. So our LCM that I've got to make each one of these is 60x to the 4th y cubed. So that means to make 12, 60, I'm going to multiply this guy on the bottom by 5. I already have x to the 4th, but I need y cubed, which means 2 more are needed to make y cubed. And what I multiply the bottom by, I've got to multiply the top by. So I'm going to multiply top and bottom by 5y squared so that I can get the y cubed. Over here, I need, again, 60, so I'm going to multiply by 12. I need x to the 4th, so I need 2 more. I already have my y cubed, so I'm good. And what I do to the bottom, I have to repeat on the top. So now when we multiply each individual question, again, I'm going to cut to the chase, and I'm going to write the common denominator underneath, which we've already determined should be 60x to the 4th y cubed. And on top, we have 25y squared minus 12x squared. And in this case, it was almost the difference of two squares. 25 is something squared, y is something squared, x is something squared, 12 is not. So we're going to leave that as is. There's no common factors between 25 and 12. And we don't cancel top to bottom because it's not multiplied. They are subtracted. So this would be our final answer. Now, I will say for whatever reason they don't talk about domain, and I just think the reason is because you've got so many variables going on that it's more of a let's get the process down. We're not going to worry about x can't be 0, y can't be 0, all that stuff. Don't be surprised if it's part of the problem in the book or in an explanation somewhere, but I know they don't require that for the answers. So the last one we're going to do for today, and then I'll load the existing notes that I've had in the past, is when we see a binomial in the denominator. And then we've got to start going back to what do we do to find our LCM. So here's a problem that we're going to do some addition. And again, we need to first factor. And we did that with our prime factorization before with the numbers. But right now, all we're worried about is each of these. So our y minus 3, we're going to end up with, in the denominator, y minus 5 and y plus 2. Shh. Then we're going to end up on the other one with y plus 2 and y minus 1. So the first thing we needed to do was factor. And I'll move it up, sorry. Then what we have to remember is each one has to have each denominator needs all factors. So we're not going to repeat any, but each denominator needs all the factors. And I'm zooming out. So each denominator needs all the factors. We need to make sure that we recognize now our LCM for this denominator is y minus 5, y plus 2, and y minus 1. So each one of these has to have one of those, all of it. So when I look back over here, the y minus 5 and the y plus 2 still needs a y minus 1. So we're going to multiply top and bottom by y minus 1. Over here we have a y plus 2 and a y minus 1, so top and bottom still needs a y minus 5. And again, we are going to just write our common denominator to save some time, so that's a y minus 5, a y plus 2, and a y minus 1. And it doesn't matter what the order is, they're just multiplied together, so it doesn't. But on top now, what I end up with, and again, just to save some space, you have a binomial times a binomial, which means we're going to do the FOIL method. First times first, first times outside, inside, last. So we end up with, on the top here, y squared minus y minus 5y plus 5. And over here in the second one, we're going to use the distributive property. And we end up with, oops, plus y squared, and then our minus 5y. So again, FOIL method, distributive property. And the last step, so our third step was we make our common denominator, our LCM. And then our fourth step is to simplify further. So whether that means combine your numerator, worry about canceling top to bottom, but we definitely need to combine the top. So I see y squared and y squared is 2y squared, minus y, minus 5y, minus another 5y looks like minus 11y, and we have plus 5. And in the bottom, y minus 5, y plus 2, y minus 1. So the only thing we need to make sure of is, can we factor the top? And I'm looking at if the AC method. And that's where the trick is. Don't stop too soon. AC method, just to check, 5 times 2 is 10. And what if I did, how do I get negative 11? Well, does that break down? What are the factors of 10 that could break down and get me negative 11 in the middle? And at least from what I can tell, 1 times 10, 2 times 5, we're not going to get any of that in the middle. So 1 times 10, 2 times 5, this is then our final answer. So keep in mind that you could factor if it was possible and check if top to bottom would work. But none of it seems, well, a negative 1 and a negative 10 would make negative 11. So let's see, y squared minus 10y minus 1y plus 5. And then we're going to factor out a 2y and get y minus 5. We're going to factor out a negative 1 and we end up with y minus 5. So we end up with y minus 5 and 2y minus 1. And if I multiplied that back together, the 5 would be a positive, the 2y squared would be here, and our middle term would end up being negative 11. So our numerator is now 2y minus 1 times y minus 5 over y minus 5, y plus 2, y minus 1. So this simplify is important that we just don't stop too soon, because our last step is to cancel these out now. And we end up with a final answer, 2y minus 1 over y plus 2, y minus 1. So that's going to be the big trick, that you're going to have to make sure that you don't stop simplifying. All right, make sure that you check Google Classroom for the already loaded notes. Make sure that you check the practice that I also loaded with all of the answers. I appreciate your patience today. Sorry for whatever went wrong, and we will check back tomorrow.